Let's go over the first method of converting a continuous system into a discrete one, which is impulse invariant transformation. So in this method, let's say you have a transfer function h of s, and if it is possible to expand h of s into partial fractions, such as this, I over s plus a1 plus b over s plus a2 plus and so on. So if it is possible to expand h of s into partial fractions, then for each of the terms, the impulse response is given as h of t is equals to I times e to the power minus i1t plus b times e to the power minus i2t and so on. So basically, impulse response is when you have a transfer function h of s and it is where you provide an impulse input delta t, and what you get as an output is h of t. So basically this is a way of doing inverse Laplace, and similarly we looked at the similar method when we were studying inverse Z transformations, is where you provide a Kronecker delta input to the transfer function, Z transfer function, and you get the response is the inverse Z transform. So in a similar way, in S domain, the impulse response is given as this. Now we can take a sampled version of h of t. So instead of h of t, we replace t with kt, except that this should be k capital T. So capital T is the sampling period. So this is equal to I e to the power minus I1 capital Tk plus b e to the power minus I2 Tk, okay T. So for each of the terms, now we can take a Z transform. Since this is in K or KT, we can take Z transforms. So h of Z will be equal to Iz over Z minus e to the power minus I1t plus Bz over Z minus e to the power minus I2t and so on. So this is basically doing a Z transform of h of S. So this is a straightforward procedure, but there are several problems with this technique, and some major problems which involve basically frequencies. So with folding high frequencies into bandwidth, which is a problem called aliasing, which we discussed in section 1. So this method demands a high sample frequency. Adding a low pass or guard filter increases the phase shift and unduly complicates mechanism, and it has a poor matching in the frequency domain. So the frequency responses of h of s and h of z do not match well.